Ladies and gentlemen, welcome back to geometry. As I told you earlier, I'm going through this way quicker than I would in class, and I'm only doing that because this thing's been disrupted 3 or 4 times due to internet connection and people coming in and out of my classroom. So try to pause it in every set of sequences here. Pause it like I would in class to give you time to work these things out instead of just copying it down and trying to figure it out just after you've copied it down. Try it first, check it next. So there's my original pre-image. Hopefully I had plenty of time to plot that. And then hopefully you work from that and you were able to go from P way over here to P prime. R flipped over the y-axis is now over here. And then E was 3 units away from the mirror, and now it's 3 units away from the mirror over on this side. So you got this new triangle on here, P prime, E prime, R prime. What I want you to do now, just like we did in the other ones, we've done it graphically, done it visually. Now we're going to look at it numerically. 5, 1 has now been moved to negative 5, 1. Negative 1, positive 1 is now positive 1, positive 1. And then E prime, it was 3, 3, now it's negative 3, 3. Very similar to the last one. If you look at just the numbers, look at the coordinates, you can easily see what happens whenever you reflect something into the y-axis. And I want to be able to write a rule for that. So I've got R sub y, a little y next to that. So a reflection into the y-axis maps an image, or sorry, a pre-image xy to, and hopefully you can write this rule on your own, negative xy. In other words, the only thing it changes is the x-coordinate. Went from 5 to negative 5, negative 1 to positive 1. So pretty easy, hopefully. This question was on the last slide, I ignored it. It says, how does E prime, in other words, a segment connecting E, a pre-image to its image, how does that segment relate to the mirror line we just reflected over? And there's 2 things going on with that. Number 1, the distance to the mirror line is the same on both sides. In other words, the mirror line is actually bisecting this E prime line. It's actually cutting it in half, which you used that when you did your reflections already. Sort of obvious. The other thing that's going on is this little segment is obviously perpendicular to the mirror line. And this is true for any reflection you do, not just these easy ones where we did a horizontal and a vertical reflection. The next one you're going to do something diagonal, but keep this sort of question. It's not on your paper yet, but we're going to answer this at the end. The mirror line is always perpendicular to whatever you're reflecting, and it always bisects the image, the distance to the image, and the distance to the pre-image. So these distances have to be the same. The reason why I'm talking about that is when you do the next one on the back, you're given these 2 triangles, and again, you should be able to take these letters and label them. Take these letters and label them pretty easily. Now we're going to do something a little trickier here. We're going to
I'll figure it out. I'm going to use all the power of my brain.
Thank you, Homer. We're going to use this little diagonal line here to reflect as our mirror line. So I want you to look at that equation for a second. Look at that line. Write the equation down for it here. Reflect the triangle into this line. Think y equals mx plus b. What's b for this line? B is 0. What's m for that line? Up 1 over 1. The slope is 1. Hopefully you realize the equation for that line is y is equal to x. A very simple equation. It happens. The reason why it's so important is it's a 45-degree angle. It's basically cutting the quadrants in half. So it's an important one to know how to reflect over. We're going to try to write a rule for this, and it's a little more complicated than the vertical and the horizontal flips you did before. I'll show you what I mean. And I'm going to start up here with point P. If I want to reflect this over the line, you have to do that diagonally. And I said a minute ago it's going to be perpendicular to that, which means this slope of this little reflection over here has to be the same, has to be an opposite reciprocal to this slope. Well, if this slope is positive 1, the reciprocal of 1 is just 1. That's easy. This is positive 1, this slope has to be negative 1. So you think of it like by slope, it's just flipping over here to another point, and I'm kind of projecting that using a negative slope. The other thing is the distance, and we haven't talked about Pythagorean theorem much, so you guys don't really know how to find distance along a diagonal. I just had the other classes count the diagonal distances. This is basically half of a diagonal into the mirror, and it should be half of a diagonal out of the mirror so that I know that this point P prime is the same distance away from the mirror as P was. And do that with all three corners, and then you'll have the triangle flipped. So if you do it with L, how many diagonals away from the mirror is that? And all you're doing is counting. It's 1.5, which means you better go out 1.5. Or a half and 1, I should say. So L prime should be up here. Hopefully that makes sense. And again, that line is also perpendicular to the original mirror on there. Has a slope of -1 as I work across. I'm going to do the same thing with F here. If you count diagonals at how far F is from the mirror, it's 3 diagonals away. 1, 2, 3 from the mirror. You would just do 3 more on the way out. And I think it is slightly off your paper, but no big deal. It's up here. You're going to start to hopefully notice something about the numbers. Look at where P ended up. It started at 3, 2, and now it's at 2, 3. There is something interesting here, so we're going to go into the numerical part of the problem. Something very interesting numerically happening to go from 3, 2 to 2, 3. Look at where L is. Where L prime is. L prime is -1, +2. If you write that down, you might automatically start to see a little pattern here. What am I doing with these to get that? What do I do with these to get that? Hopefully it's obvious that these are just switching. X, Y is flipping around. Now it's YX. They've reversed. If that worked, 5, -1 should become -1, 5. -1, 1, 2, 3, 4, 5. It works to find F prime. So this is, you've sort of kind of coming up with this way to predict any reflection into this line y = x is just going to reverse the coordinates. Try it with BIG. Try to just do it either, and you can do it graphically. You can just look and go, okay, I'm 1 diagonal away from the mirror. I'm going to go 1 diagonal away. Half of a diagonal, I'm going to go half a diagonal. 1 diagonal, 1 diagonal. Or you can try to use this little trick, this little rule about functions, where you just reverse the coordinates. I'm going to stop here. I'm back in the last part in a moment. So give it a try. See if you can get B prime, I prime, and G prime. I'll be back to write the rule in a moment.